All right, today we're going to be reviewing angles, and I just want to touch base and make sure that we all realize that an acute angle is less than 90 degrees, and that the right angle always has to have that little box in the corner. An obtuse angle is greater than 90 degrees, and a straight angle is exactly 180 degrees because it's a straight line. Okay, so that's in your toolkit. That's on page 77. You're going to need your toolkit as we go over these angles. Now I'm going to page 78. 78 talks about a bunch of different angles, and the first one I want to talk about is complementary angles. Complementary angles are angles that equal 90 degrees when added together. It can be 2 angles, it could be 5 angles, but they all would equal 90 degrees when put together. Okay? The next pair is complementary. Complementary means they equal 180. So again, it could be 1 angle or it could be 10 angles that equal that. Notice that there's pairs of them below these that are separate, and we can say that they are supplementary or complementary pairs, even though they're not connected like the first 2 angles. Then, at the bottom, we're talking about adjacent and vertical angles. So here in this picture, C and G are across from each other in this intersection, and they are called vertical angles because they are across from each other. Here's the key. Vertical angles are opposite angles that form 2 intersecting lines. Okay? They are equal. So the last sentence here, where it says vertical angles always have equal measure, that's important to remember. So if they're across from each other in this intersection, they're equal to each other. So the other term is adjacent angles, and adjacent angles are angles that are next to each other. So they're angles that are side by side. So in this case, C and D are side by side, they're adjacent, they're touching, they share that common ray, okay? Or D and G are a pair of adjacent angles. Okay, we go the whole way around. G and F are adjacent, and F and C are adjacent. So we could also go back up to the top, and we could look at that first pair right here, and A, now I can't read that, ABC is adjacent to CBD, and the same in the supplementary pair, that EFG would be adjacent to angle GFH. All right, so let's take a look at a couple examples. The first example, I'm hoping you're saying, oh, that's a complementary example because it has a 90-degree angle symbol. So we're going to be finding the measure of these angles. So if a complementary pair of angles should equal 90 degrees, and we're given one measure, we're going to do 90 minus 77. So 90 minus 77, and that would give us 13 degrees for that missing angle. So let's look at a trickier one where we have a variable. So we still know that this pair of angles should equal 90 degrees. So we're going to write an equation, and our equation is going to be 3x plus 2 plus 55 equals 90, and then we're going to solve this. So first I'm going to combine the 2 and the 55 to get 57. Okay, and we're going to solve this just like we normally would an equation. Subtract 57. 90 minus 57 gives me 33, and that equals 3 times x. So now I'm going to divide by 3. So x in this case is 11. All right, let's take a look at a supplementary pair. Remember, these equal 180 degrees. So 107 degrees subtracted from 180 gives us 73 degrees. Okay, now we're going to apply that with some more variables. We're going to look at an equation, and this equation is going to be both the angles added together, and has to equal 180 degrees this time. Okay, and I'm going to combine that -8 with the positive 125. So negative 8 plus 125 gives us x over 2 plus 117 equals 180. So our first step would be to get rid of the 117. So 180 minus 117 would leave us with 63 equals x over 2. So this is x divided by 2. So to get x by itself, we're going to multiply by 2. So 63 times 2 gives us 126. So in this case, x is 126. And here's your check. Put it back in for x over here, and 126 over 2, which would be divided by 2, is 63. And 63 minus 8 would give me 55. So does 55 degrees and 125 degrees equal 180? Yes, it does. All right, changing gears, and we're now looking at angles that are intersecting, and we want to look at the angles that are going to be vertical first. So angles 2 and 4 are vertical angles. They will be equal to each other. So if angle 4 is 83 degrees, then angle 2 is also going to be 83 degrees. Now, this is an interesting setup because this is what happens here. This is a straight line right here. Straight line. Straight line equals how much? 180 degrees. So that means that angle 4 and 3 should equal 180 degrees. So if we know 4, and 4 is 83, we can find the other one by subtracting. 180 minus 83 gives me 97 degrees. So that makes angle number 3 97 degrees. So if 3 is 97 and 1 is vertical to 3, so let's show this. Let's pick a different color. Angle 3 and angle 1 are vertical. So angle 1 is also going to be 97 degrees. All right, let's apply that now. Here we have a set of angles, and I'm going to mark the ones that are going to be vertical first. Okay? So this angle here is a vertical angle with this angle, which means they're equal. Okay? Which then means the other two that are left, this one and this one, are vertical. Vertical angles are equal to each other. They have the same measure. So that means that x plus 21 has to equal 147. So solve it like it's an equation. 147 minus 21 gives us x equaling 126. So the measure of angle POS, so that's this angle here. Remember, it makes that straight line. Okay? So 180 minus 126 is going to be 54 degrees.